Hello students, I am Sir Glenn, your subject teacher. Welcome to Pre-Calculus. Our topic is all about the different circular functions. But before that, we need to recall the basic trigonometric ratios that were taught during your grade 9 mathematics. So we have this mnemonic, SOHCAHTOA and CHO-SHAKAO. So SOHCAHTOA represents the first three trigonometric ratios, and then CHO-SHAKAO are the corresponding reciprocals of the first three trigonometric ratios. So what is SOHCAHTOA and what is CHO-SHAKAO? So that is based on a right triangle. So we have the angle, and then the longest side is the hypotenuse. The opposite side of the angle is indicated there, the opposite side, and then the adjacent side is the side which is closest to the angle. So SO stands for sine, and then opposite all over hypotenuse. And then KA stands for cosine theta is equal to adjacent all over hypotenuse. And then TOA stands for tangent theta is equal to opposite side all over adjacent side. CHO stands for cosecant theta is equal to hypotenuse all over opposite side. Secant theta is equal to hypotenuse all over adjacent side. And then CAO stands for cotangent theta is equal to adjacent side all over opposite side. So these are the basic trigonometric ratios. Sine, cosine, and tangent are the first basic trigonometric ratios, and then cosecant, secant, and cotangent are their corresponding reciprocals. Cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and then cotangent is the reciprocal of tangent. So we have circular functions. Circular functions are functions whose domain and range correspond to the measures of angles with respect to the trigonometric functions. These functions are defined using the unit circle. So we have this unit circle. By definition, a unit circle is a circle whose radius is always equal to 1. So the radius is 1, and then we have this angle, and then the adjacent side of the angle is x, and then the opposite side with respect to the angle is y. So in a unit circle, circular functions are derived by creating a right triangle, and then knowing trigonometric functions, trigonometric ratios, they are derived from a right triangle. So let's talk about the coordinates of quadrantal and first quadrant angles. A quadrantal angle is an angle in standard position whose terminal side lies along one of the axes. So quadrantal angle siya kung ang kanyang terminal side ay nakapaloob sa mismong x-axis or y-axis. So ito yung representation ng mga quadrantal angles. For example, ang 90-degree quadrantal angle siya. 180 is also a quadrantal angle, 270 is a quadrantal angle, and 360 is a quadrantal angle. So quadrantal angle sila kasi yung kanilang terminal side ay nakapaloob sa mismong x-axis or y-axis. So ang kanyang mga coordinates ay kapag 0 degree or 360 degrees, ang coordinates niya ay 1, 0. Pag 90 degrees, 0, 1. Kapag 180, negative 1, 0. Kapag 270 degrees, 0, negative 1. At kapag 360 degrees, 1 and 0. Let us consider the first quadrant and identify the coordinates of the first quadrant angles. So first quadrant lang muna ang focus natin kasi mamaya when we talk about reference angles, malalaman natin na pwede nating maging basis yung mga coordinates doon sa mga first quadrant angles natin. Maiiba lang yung kanyang sign, depende kung saang quadrant ba sila nakalagay. In trigonometry, there are three special reference angles. These are 60 60 degrees, 45 degrees, and 30 degrees. To know the coordinates of these angles, we need to learn two important triangle theorems: the 30 degree, 60 degree, and 90 degree theorem, and the 45 degree, 45 degree, and 90 degree theorem. Let's talk about the first theorem, 30 degree, 60 degree, and 90 degree triangle theorem. It states that the length of the hypotenuse is twice the length of the shorter leg, and the length of the longer leg is square root of 3 times the length of the shorter leg. So let's focus our attention first in the 30 degree angle. So the angle between the initial side and terminal side is 30 degrees. The hypotenuse is 1. So as you can see in the figure, the hypotenuse is also the radius, and since we are talking about a unit circle, its radius is equal to 1, therefore our hypotenuse is 1. Since it is twice the length of the shorter leg, which is y, then y is equal to 1/2. The longer leg, which is x, is square root of 3 times the shorter leg. Thus, x is equal to square root of 3 times 1/2. So we have square root of 3 times 1 is square root of 3, and then 1 times 2 is equal to 2. So therefore, the point where the terminal side of 30 degrees intersect the unit circle is point P, which has coordinates square root of 3 all over 2 and 1/2. So labeling this diagram and placing the coordinates, we have, so the adjacent side of 30 degrees measures square root of 3 all over 2. The opposite side is 1/2. So therefore, our coordinates for this angle is square root of 3 all over 2 and 1/2. How about if our angle is 60 degrees? The angle between the initial side and terminal side is 60 degrees. The hypotenuse is 1. Since it is twice the length of the shorter leg, which is x, then x is equal to 1/2. The longer leg, which is y, is square root of 3 times the shorter leg. Thus, y is equal to square root of 3 times 1/2 is equivalent to square root of 3 all over 2. Therefore, the point where the terminal side of 60 degrees intersect the unit circle is P, which has coordinates 1/2 and square root of 3 all over 2. So labeling this diagram with the result that we obtained, we have the adjacent side of a 60 degree angle is 1/2. The opposite side is square root of 3 all over 2. So therefore, our coordinates are 1/2 and is square root of 3 all over 2. So kung mapapansin ninyo, pareho lang, may pagkakapareho silang dalawa. Ang kinaibahan lang, kay 30 degree, ang kanyang x value ay square root of 3 all over 2. Kay 60 degree, yung square root of 3 all over 2 ay magiging y value niya. Pinagpalitan lang po silang dalawa. Pinag-swap lang yung x at y nila. So for the second theorem, 45 degree, 45 degree, 90 degree triangle theorem, the legs are congruent and the length of the hypotenuse is square root of 2 times the length of either leg. So we have this figure. The angle between the initial and the terminal side is 45 degrees. The hypotenuse is 1. Since it is square root of 2 times the length of either leg, then we have h is equal to x times square root of 2. X represents the length of either leg. Since we are talking about an isosceles triangle here, isosceles right triangle, so the sides are equal. So substituting h, which is equivalent to 1, then 1 is equal to x square root of 2. So divide both sides by square root of 2 to get rid of square root of 2 on the right side. At ang may iwan na lang ay si x. So therefore, x is equal to 1 all over square root of 2. Since mayroong radical symbol sa baba, kailangan natin siyang i-rationalize para ma-simplify. So Doing so, we multiply square root of 2 over square root of 2. Simplifying this, we have 1 times square root of 2 is square root of 2, and then square root of 2 times square root of 2 in the denominator is equal to square root of 4. So simplifying further, we get square root of 2 all over 2. Then, the length of either leg is square root of 2 all over 2. So therefore, the point where the terminal side of 45 degrees intersect the unit circle is point P, square root of 2 all over 2, and square root of 2 all over 2. So labeling this diagram with the result that we obtained, we have the adjacent side is square root of 2 all over 2. The opposite side is square root of 2 all over 2. So our coordinates, we have square root of 2 all over 2 and square root of 2 all over 2. Putting all the information about the quadrantal and special angles in the first quadrant, we obtain this diagram. So take note, if the angle between the initial side and the terminal side is 30 degrees, our coordinates are square root of 3 all over 2 and 1/2. Kapag 45 degrees naman siya, we have square root of 2 all over 2 and square root of 2 all over 2. At kapag 60 degrees naman, we have x is 1/2 and y is square root of 3 all over 2. So, example 1. Give the coordinates x, y of the following degree measures. So, we'll be making use of this diagram. So, the angle is 180. Our coordinates, we have negative 1 and 0. Kung 90 siya, looking at our diagram, we have 0, 1. Kapag 60 degrees siya, ayon sa diagram, we have 1/2 and square root of 3 all over 2. At kung 45 degrees naman siya, we have square root of 2 all over 2 and square root of 2 all over 2. So, suppose the terminal side of angle theta in standard position intersects the unit at point xy as shown below. Since the radius is 1 and the radius is also the hypotenuse of the triangle, then sine theta and cosine theta will become sine theta is equal to opposite side all over hypotenuse. So we know that our opposite side is y and our hypotenuse has measure 1. So y divided by 1 is equivalent to y. So cosine theta is equivalent to adjacent side all over hypotenuse. So adjacent side is x and then hypotenuse is 1. So x divided by 1 is equivalent to x. So therefore, the x coordinate of each point in the unit circle is the cosine function, while the y coordinate of each point in the unit circle is the sine function. So example 2. Find the values of cosine 30 degrees and sine 45 degrees. So we have this solution. Of course, we will be needing this table, but if you already mastered, if you already memorized the coordinates of these angles, then no need to refer to this table. From the table on the upper right, 45 degrees has coordinates square root of 2 all over 2, square root of 2 all over 2, and 30 degrees has coordinates square root of 3 all over 2 and 1/2. Since cosine theta is equal to x and sine theta is equal to y, then cosine 30 degrees is square root of 3 all over 2 and sine 45 degrees is square root of 2 all over 2. Let us now obtain the other four circular functions. Since nakuha na natin yung dalawa, sine theta is equal to y and cosine theta is equal to x, let's now try to obtain the other four. Since cosine theta is equal to x and sine theta is equal to y, then we have tangent theta is equal to y all over x, which is equivalent to sine theta all over cosine theta. So in order to find the value of tangent theta, we just divide sine theta by cosine theta. Secant theta is the reciprocal of cosine theta. So we have secant theta is equal to 1 all over x So that is equivalent to 1 all over cosine theta. So to obtain the value of secant theta, we just get the reciprocal of our cosine, the value of cosine theta. Cosecant theta is the reciprocal of sine theta. So we have cosecant theta is equal to 1 all over y. That is equivalent to 1 all over sine theta. So to obtain the cosecant, the value of the cosecant theta, we just obtain the reciprocal of sine theta. And cotangent theta is the reciprocal of tangent theta. So we have cotangent theta is equal to 1 all over tangent theta, or that is equivalent to 1 all over tangent theta is equivalent to sine theta all over cosine theta. So simplifying that, we can derive at cosine theta all over sine theta. So in short, to obtain the value of cotangent, we just obtain the reciprocal of tangent theta. Example 3. Find the circular functions of 60 degrees. So we refer to this table. From the table on the upper right, 60 degrees has coordinates 1/2 n square root of 3 all over 2. Since cosine theta is equal to x and sine theta is equal to y, then cosine 60 degrees is 1/2 and sine 60 degrees is square root of 3 all over 2. For tangent 60 degrees, we have tangent 60 degrees is equal to sine 60 all over cosine 60. We know that sine 60 is square root of 3 all over 2 and cosine 60 is 1/2. So division involving fractions ito. So this will become multiplication, and then the divisor, we will get the reciprocal of the divisor. So square root of 3 all over 2 times the reciprocal of 1/2 is 2 all over 1. So square root of 3 times 2 is 2 square root of 3, and 2 times 1 is equivalent to 2. So we can still simplify this. 2 divided by 2 is 1. 1 times square root of 3 is square root of 3. So the value for tangent 60 is square root of 3. For secant 60 degrees, we have secant 60 degrees is equal to 1 all over cosine 60 degrees. We know that cosine 60 is 1/2. So 1 divided by a fraction, so it will be multiplication. The divisor, we get the reciprocal. So 1 times 2 all over 1. So that is equivalent to 2. Secant 60 degrees is equivalent to 2. For cosecant 60 degrees, cosecant 60 degrees is equal to 1 all over sine 60. And sine 60 is equivalent to square root of 3 all over 2. So 1 divided by a fraction, so it will become multiplication. We consider the reciprocal of the divisor. So 1 times 2 is 2. And then 1 times square root of 3 is square root of 3. Since mayroon siyang radical symbol sa baba, we simplify, we rationalize. So we multiply square root of 3 all over square root of 3. So it will give us 2 square root of 3 all over square root of 9 as the result. So simplifying this, we have 2 square root of 3 all over 3. So that is the value of cosecant 60. And for cotangent 60 degrees, we have cotangent 60 is equal to 1 all over tangent 60. So tangent 60 is square root of 3. So 1 all over square root of 3, since there exists a radical symbol in the denominator, we need to rationalize. So we multiply square root of 3 all over square root of 3. So that will give us square root of 3 all over square root of 9, which is equivalent to square root of 3 all over 3. So therefore, the 6 circular functions of 60 degrees are cosine 60 degrees is equal to 1/2, and then its reciprocal is secant 60 is equal to 2. Sine 60 is equal to square root of 3 all over 2. Ang kanyang reciprocal ay cosecant 60 is equal to 2 square root of 3 all over 3. Tangent 60 is equal to square root of 3. Ang kanyang reciprocal ay cotangent 60 degrees is equal to square root of 3 all over 2. So let's now evaluate circular functions using reference angles. A reference angle is the acute angle formed by the terminal side of a given angle in standard position and the x-axis. So siya yung pinakamaliit na angle na mabubuo using the terminal side and the x-axis. So we have this image, standard angle yung green na theta, and then reference angle yung theta prime. So for the first quadrant, ang standard angle ay siya ring reference angle. For quadrant 2, kapag yung angle ay nag-stop doon sa pangalawang quadrant, ang kanyang reference angle ay yung terminal side at yung x-axis. Yung angle formed by the terminal side and the x-axis. Same is true kay quadrant 3 at quadrant 4. The reference angle is always made positive whichever quadrant and what direction, either counterclockwise or clockwise, is the given angle. So, laging positive ho sa reference angle. Finding the reference angle in each quadrant, we have quadrant 1, same as the angle. Pag nasa quadrant 2 yung angle na yon, then 180 minus theta. Kapag nasa quadrant 3, then theta minus 180. Kapag quadrant 4, we have 360 minus theta. We have a note here for negative angle, neglect the negative sign. So kapag negative yung angle na yon, wag nang i-include yung negative in measuring the reference angle ha. So example, find the reference angles of the following angles in standard position. We have A, 210 degrees. So our solution, since the given angle is in the third quadrant, then we have theta minus 180. So that is 210 minus 180 is equivalent to 30. So therefore, the reference angle is 30 degrees. Letter B, negative 125 degrees. So our solution, disregarding the negative sign, 125 degrees is in the second quadrant. Then we have 180 minus theta is equal to 180 degrees minus 125 degrees is equal to 55 degrees. So therefore, the reference angle for negative 125 is 55 degrees. The use of reference angles is a way to simplify the calculation of the values of trigonometric functions at various angles. Using the rules of reference angles to find the exact values of the circular function, the following angles of the basic circular functions of the unit circle for certain acute angles and the rule of sines of the circular functions will be useful. So ito ho yung kanyang table. So yung value ni sine, ni cosine at ni tangent, nakadepende ho kung anong angle yung given. Kung 30 degree ba or pi all over 6 for the radian measure, kung 45 degrees ba or pi all over 4, 60 degrees or pi all over 3, and 90 degrees or pi all over 2. And for this rule of sines, kapag quadrant 1, lahat po ay positive. Kapag quadrant 2, ang positive lang ay sine at yung reciprocal niya, which is si cosecant. Quadrant 3, ang positive lang ay si tangent at si cotangent. At si quadrant 4, ang positive lang ay si cosine at si secant. So we can also use this table, this diagram, if hindi natin ma-memorize agad-agad yung mga values at yung process ng paghahanap ng values manually. Okay? So example 5, use reference angle and the appropriate sign to find the exact value of each expression. Let's begin kay A. Sine 11 pi all over 6 and cosine 11 pi all over 6. The reference angle of 11 pi all over 6 is pi all over 6. Since pi all over 6 or 30 degrees has coordinates square root of 3 all over 2 and 1/2, and 11 pi all over 6 is in the fourth quadrant, then sine is negative and cosine is positive. Therefore, sine 11 pi all over 6 is equal to negative 1/2, and cosine 11 pi all over 6 is square root of 3 all over 2. So, ang naging basis natin dyan ay yung mga result na nakuha natin doon sa mga first quadrant angles. And then, ang final result natin ay nakadepende ho sa kung saang quadrant nakalagay yung angle natin. Since nasa pang-apat na quadrant siya, at knowing yung pang-apat na quadrant, yung cosine ay positive at si sine ay negative, so binago natin yung signs. Okay, so sine 11 pi all over 6 is negative 1/2 and cosine 11 pi all over 6 is square root of 3 all over 2. For item B, we have cosine negative 7 pi all over 6. The reference angle of negative 7 pi all over 6 is pi all over 6. Since pi all over 6 has coordinates square root of 3 all over 2 and 1/2, and negative 7 pi all over 6 is in the second quadrant, then cosine is negative. Therefore, cosine negative 7 pi all over 6 is equal to negative square root of 3 all over 2. For the third item, we have sine 150 degrees. The reference angle of 150 degrees is 180 minus 150, we have 30. Since 30 degrees has coordinates square root of 3 all over 2 and 1/2, and 150 is in the second quadrant, then sine is positive. Therefore, sine 150 is equal to 1/2. For the fourth item, tangent 8 pi all over 3. So our solution, the reference angle of 8 pi all over 3 is pi all over 3. Since pi all over 3 has coordinates 1/2 and square root of 3 all over 2, and 8 pi all over 3 is in the second quadrant, then sine is positive and cosine is negative. Then, sine 8 pi all over 3 is equal to square root of 3 all over 2, and cosine 8 pi all over 3 is equivalent to negative 1/2. Solving for tangent 8 pi all over 3, then we have tangent 8 pi all over 3 is equal to sine 8 pi all over 3 all over cosine 8 pi all over 3. So we have square root of 3 all over 2 all over negative 1/2 since division using a fraction ito, we replace the operation to multiplication and we get the reciprocal of the divisor. So square root of 3 all over 2 times the reciprocal of negative 1/2, which is negative 2. So simplifying this, we have negative square root of 3. So therefore, tangent 8 pi all over 3 is equivalent to negative square root of 3. For the last item, cotangent 225 degrees. So our solution, the reference angle of 225 is 45 degrees. Since 45 degrees has coordinates square root of 3 all over 2, square root of 2 all over 2 I mean, and square root of 2 all over 2, and 225 degrees is in the third quadrant, then sine and cosine are both negative. Therefore, cotangent 225 is equal to cosine 225 all over sine 225, so which has values negative square root of 2 all over 2 and negative square root of 2 all over 2, or that is equivalent to 1. So that is how we obtain the exact value of the different circular functions using the reference angle and of course using the coordinates that we obtained in the first quadrant. So if the given angle is in degree measure, then madali lang siya. Pero kapag region measure, madali lang din siya kung kabisado mo na. But if you are having difficulty in trying to figure out the exact value of a circular function whose angle is in region measure, yung may pi, okay lang na i-convert mo muna siya to its equivalent degree measure para mas madali. Okay? Thanks for watching. Please subscribe to my channel for more math videos.